Dear viewers, I hope you are well. Today I say about 10 must know statistical concept for data scientist. Data science is an interdisciplinary field. One of the building blocks of data science is statistics. Without a decent level of statistics knowledge, it would be highly difficult to understand data. Statistics helps us explain the data. We use statistics to infer result about a population based important from that population. Furthermore, machine learning and statistics have a plenty of overlaps. Long history short, one need to study and learn statistics and its concept to become a data scientist. So at first is population and the sample. Population is all element is a group. For example, college students in US is a population that include all of the college students in US. 25-year-old people in Europe is a population that include all of the people that fits the description. It is not always feasible or possible to do analysis on population because we cannot collect all the data of a population. Therefore, we use samples. Sample is a subset of a population. For example, 1,000 college students in US is a subset of college students in US population. Second, normal distribution. Probability distribution is a function that shows that the probabilities of the outcomes of an event or experiment. Consider a features in a data frame. This feature is a variable and its probability distribution function shows the likelihood of the values it can take. Probability distribution functions are quite useful in predictive analysis or machine learning. We can make prediction about a population based on the probability distribution function of a sample from that population. Normal distribution is a probability distribution function that looks like a bell. The following figure illustrates the shape of a typical normal distribution curve, which was created by using a random sample returned by numpy.random function of numpy. The peak of the curve indicates the most likely value the variable can take. As we move away from the peak, the probability of the values decreases. The following is a more formal representation of a normal distribution. The percentages indicate the percentage of data that falls in that region. As we move away from that mean, we start to see more extreme values with less probability to be observed. Third, measures of central tendency. Central tendency is the central value of a probability distribution. The most common measures of central tendency are mean, median, and mode. Fourth, variance and standard deviation. Variance is a measure of the variation among the values. It is calculated by adding up squares differences of each value and mean and then divided the sum by the number of samples. Fifth, covariance and correlation. Covariance is a quantitative measure that represents how much the variation of the variables match each other. To be more specific, covariance compares two variables in terms of the deviation from their mean value. The figure below shows some values of the random variable x and y. The orange dot represents the mean of that variable. The values change similarly with respect to the mean value of the variable. That there is a positive covariance between x and y. Central limit theorem. In many fields, including natural and social science, when the distribution of a random variable is unknown, the normal distribution is used. Central limit theorem justifies why normal distribution can be used in such cases. According to the CLT, as we take more sample from a distribution, the sample average will tend towards a normal distribution regardless of the population distribution. Consider a case that we need to learn the distribution of the height of all 20-year-old people in a country. It is almost impossible and of course not practical to collect this data. So we take sample of 20-year-old people across the country and calculate the average height of the people in that sample. CRT states that we take more sample from the population. Sampling distribution will get close to a normal distribution. Why it is so important to have normal distribution? Normal distribution is described in terms of mean and standard deviation, which can easily be calculated. And if we know the mean and standard deviation of a normal distribution, we can compute pretty much everything about it. 7. P-value. P-value is a measure of the likelihood of a value that a random variable takes. Consider we have a random variable a and the value x. The p-value of x is the probability that a takes the value x or any value that has the same or less chance to be observed. The figure below shows the probability distribution of a. It is highly likely to observe a value around 10. As the value gets higher or lower, the probabilities decrease. We have another random variable b and want to see if b is greater than a. The average sample means obtained from b is 12.5. The p-value for 12.5 is the green area in the graph below. The green area indicates the probability of getting 12.5 or more extreme value. Say the p-value is 0.11. But how do you interpret it? A p-value of 0.11 means that we are 89% sure of the result. In other words, there is 11% chance that the result are due to random. Chance similarity, a p-value of 0.05 means that there is a 5% chance that the results are due to random chance. 8. Expected value of random variables. The expected value of a random variable is the weighted average of all possible value of the variable. The weight here means the probability of the random variable taking a specific value. The expected value is calculated differently for discrete and continuous random variables. Continuous random variables take infinitely many values. For instance, the time it takes from your home to the office is a continuous random variable. Depending on how you measure it, it takes uncountably infinitely many values. 9. Conditional probability. The probability simply means the likelihood of an event to occur and always takes a value between 0 and 1. The probability of event A is denoted as PA and calculated as the number of desired outcome divided by the number of outcomes. For example, when you roll a die, the probability of getting number less than 3 is 2 by 6. And also conditional probability is likelihood of an event A to occur given that another event that has a relation with event A has already occurred. Suppose that we have a 6 blue balls and 4 yellow placed in 2 boxes as seen below. I ask you to randomly pick a ball. The probability of getting a blue ball is 6 by 10 equal to 0.6. When if I ask you to pick a ball from a box A, the probability of picking a blue ball clearly decreases. The condition here is to pick from box A, which clearly changes the probability of that event. Bayes' theorem is so fundamental and ubiquitous that a field called Bayesian statistics exists. In Bayesian statistics, the probability of an event or by hypothesis as evidence comes into play. Therefore, prior probabilities and posterior probabilities differ depending on the evidence. Naive Bayes algorithm is structured by combining Bayes theorem and some naive assumptions. Naive Bayes algorithm assumes that features are independent of each other and there is no correlation between features. Conclusion. We have covered some basic and yet fundamental statistics concepts. If you are working or plan to work in the field of data science, you are likely to encounter this concept. So, thank you, brother, for participate at the video. So I hope you learn something from this video. Thank you. Subscribe my channel.